Okay, good morning class. So today we're looking at exercise, the examples for exercise 3. And exercise 3 is on page 54. If you just follow, if I make no mistake. And if I do, please let me know. I can't find my textbook now, I'm not going to look for it. There we go. We're on the next page. Exponential functions and the inverses. Is that correct? This is examples for exercise 3. And this exercise 3 is on page 54. Alright, so exponential functions and the inverses. In topic 2 you learned that to find an inverse of a function, you swap x and y and rewrite y in terms of x. For all exponential functions, if f of x is equal to y is equal to x, where a is greater than 0, that has to be positive, a can't be 1. Then for the inverse function, you interchange x and y. Not so? So x is equal to a to the y. So if you got a to the y, a to the y, then I can change this to log format. Not so? So that's the subject of your formula. So it y is equal to log x base a. Remember, the base remains the base. Okay. Then if f of x is equal to 1 over a to the x, where a is greater than 0 but less than 1, then for the inverse function, again you interchange x and y. So x is equal to 1 over a raised to the y. Make y the subject of the formula. Y is equal to log x base 1 over a. But this is something I need to show you at this point as well. That if you got y is equal to 1 over a raised to the x. But 1 over a can be also written as a to the minus 1. So this could also be written as a to the minus x. Not so? So if we go for the inverse function, we interchange x and y, so x is equal to a to the minus y. So now if we change it now to logs, it now reads negative y is equal to log x base a. There's always need to be positive, not so? So y is equal to log x, negative log x base a. Can you see that? And we can prove that as well. Okay, let's just take you somewhere in this space. So if you got log, let's go first 1 over a base x, then we know 1 over a can be written as log a to the minus 1 of x. Not so, but where must this negative 1 go? In front. So that is negative log a base x. Can you see that? Otherwise, if you got log a base 1 over x, which is the one we just did now. So this can be written as log a over log 1 over x. Not so. Remember that the rule that we said? That log a base b can be written as log a base c over log b base c. So what did I make the base here? 10 years. Okay. So 1 over x can be written as x to the minus 1. So it's log a over log x minus 1. Where can this be written? Front. So that's going to be negative log a over log x. But remember, if it's written as log a base c over log b base c, it can be written as log a base b. With the denominator, as number becomes its base. You see that? So that is simply negative log a base x. You see that, people? So there is, as you can see, a link between that as well. Okay. So that is just to keep that in mind. Later on we will apply that to a sum or something. Okay. And you'll see exactly how it's applied. Right, worked example. Let's look at the first thing here. And which page is that example on? Sorry? 52. Okay. So draw the graph of f of x equal 2 to the x and its inverse on the same set of axes. So where do we start? We start by saying f of x is equal to 2 to the x. For this graph, we draw a table. So that's an x and a y. The values we choose is negative 0, 1 and 0. And negative 1, 0 and 1. Okay. So if you substitute negative 1 in here, what do we get? 2 to the negative 1. Oh, 2 to the 0, 1. 2 to the 1. You all agree with that? So if we draw this graph, so here we go, y, x 0, minus 1, minus 1. It's 1, 2. Okay. So when we go, x is minus minus 1, y is r. Okay, if x is 0, y is 1. If x is 1, y is 2. So if the graph comes close to the x-axis, doesn't touch. This is your graph of you all agree? When we draw the graph, it must be clear to us what is the shape of this graph. The y-intercept must be known and at least one point on the graph, either this one or that. Okay. If you write both, no problem. See any confusion at this point? Now the question says, and its inverse f to the minus 1 on the same system axis. So if I take the inverse, what happens? We interchange x and 1. So 1 and 2 becomes 2 and 1. This is 0 and 1 becomes 1 and 0. Minus 1 and a half becomes half and minus 1. The horizontal asymptote, when it's reflected, it becomes the vertical asymptote. Can you see that, people? So the graph again comes close, doesn't touch. There's your first look at what a log graph looks like. Okay, this is a log graph. Okay? So this is your inverse function. And this is always reflected in the line. Why is it? As you can see there, if I fold this graph close in this line, then that graph fits exactly onto that graph. It maps exactly onto that. The domain becomes the range and the range becomes the domain. Do you guys understand? Is there any confusion? Now the question says, write the inverse of f in the form of y equals. Write the inverse in that form. So it's now number 2. People, what do we do for the inverse function? We're going to interchange x and y. Now f of x is your 1. So y is equal to 2 to x. So what's the inverse function? X is equal to 2 to the 1. So you want to write this in log form, or you want to make y the subject of the formula. Therefore y is equal to log x base 2. And that's the inverse of f. So therefore f to the minus 1 is equal to y, which is equal to log x base 2. Okay. This wasn't asked, but let's answer the domain of f and the range of f. What's the domain of the inverse of f and the range of the inverse of f? What's it? The f graph is the graph in red, not so. The original graph. This goes to negative infinity and positive infinity, not so. So what's the range? X is an element of all real numbers. Let's look at the range. Does this graph exist at negative infinity? No. Where does it start existing at? At 1. From 0 here. 0 onwards. So we say y is greater than. People cannot be equal. Equal to 0. Greater and equal to 0. Why not? So that's the term. Okay. Let's look at the inverse domain. Does this graph exist at negative infinity? Huh? Does the graph in blue exist at negative infinity? No. Where does it start existing at? 0 onwards. So in other words, x is greater than 0. This graph goes negative infinity, positive infinity. So all the values between for y, not so. So we say y is an element of order 1. As you can see there, the domain of the function becomes the range of the inverse function, whilst the range of the inverse function becomes the domain of the function. Okay. As I said, this question was not asked. Okay. Look at the work example on page. Sorry? Page 50. Here we are told given f of x equal to 3 to x. Write down the equation of these graphs in the form of y equals. Okay. So the first question is reflection in the y-axis. People, what is the rule if something is reflected in the y-axis? X becomes negative. So this is your y, not so. So we now say y is equal to 3 to the minus x. And this is the equation of g of x. Or you can say g of x is equal to 1 over 3 raised to the x. Let's look at 1.2. 1.2. Reflection of f. So I go again to the original. If I had to say reflection of g, then I would have had to go with this one. Can you see that, people? Reflection of f in the x-axis. So if something is reflected in x-axis, what's the rule? Y becomes negative. Not so. So you got negative y is equal to negative y is equal to 3 to the x. So therefore, divide by negative, y is equal to negative 3 to the x. And this is the equation of h of x. Okay? Oops. So 1.3. The inverse of f. So what do I do for the inverse function? Remember, this is your f, no? We're going to interchange x and y. So x is equal to 3 to the y. So you want to make y the subject of the formula. Therefore, y is equal to log x base. And this is the inverse. People, is the inverse a function? If you look at this graph here, is this inverse a function? And what type of function is it? So 1 to 1. Every 1x is 1 1. Can you see that? So it's a 1 to 1 function. 1.4. The inverse of g. So what is g of x? Either one of these two. Not so. So let's do both. You don't have to do both. I'm just showing you if you had gone with one and not the other. We look at the inverse here. So what we do, we interchange x and y. So x is equal to 3 to the minus 1. So now can be written as negative y is equal to log x base 3. So y is equal to negative log x base 3. All agree with that? If you had gone with g of x equals a third to the x, and I go for the inverse function, what do I do here? Interchange x and y. So x is equal to log, no, x is equal to a third to the 1. So therefore, y is equal to log x base a third, which is the inverse function there as well. You all agree with that, people? Can you see? What's the difference? That is 3, there's a negative here. Otherwise, if that's a third, it is positive. Okay. Yes? Sorry? If you had chosen this one? Yeah? This one? It's fine. It doesn't matter. We mark both. Okay, so you're asking if you go on with that initially, but then you change it to this, and then you go there, full marks, go with that, full marks, that. Always. Like all of it also full marks. Okay. Not going to get extra. Okay. People, then it says draw the graph of f and its inverse on a set of axes showing all intercepts with axes. So what is the f of x graph? F of x is equal to 3 to the x. So if f of x is equal to 3 to the x, where do we start? Start with a table. Not because we're hungry. That's the easiest way to do it. Okay. Put negative 1 in, what do we get? A third, 1 in. So that's enough information to draw this graph. With y in your x, minus 1, 0 and 1. 1, 2, 3. Minus 1, minus 2, minus 3. Knowing that's going to be a bit bigger. So 1, 2, 3. It's all by approximation, eh? Alright, so negative 1 is worth a third. That is off, so a third is approximately there. 0 and 1 is there. And 1 and 3. Of course. As we know, this is an asymptote here. The graph comes close, but doesn't touch. That is the graph of f of x. Okay. What do we do for the inverse function? We interchange x and y. So 1 and 3 becomes 3 and 1. So as you can see, it's in line with that. And then 1 and 0, 0 and 1 becomes 1 and 0. Negative 1 and a third becomes a third and negative 1. Graph comes close but does not touch. This is the inverse function. And is it reflected in the line? Y is equal to? So draw the graph of f and its inverse on the same set of axes, showing all intercepts of the axis. Intercepts is where it cuts the axis. Okay. So any confusion there? Right? So that question 3 must be a 3, yes? In number 3 we are asked, use your graph, which is this here, to determine the value for x for which f of x times g of x is less than or equal to 0. People, what does less than or equal to 0 mean? Means to say it is negative. Something is less than 0, it's negative. Under what condition, when we multiply two numbers, is it negative? One is positive and the other one is negative, or one is negative and the other one is positive. So when is a graph positive? It is lying above the x-axis. Can you see all the positive values for y? And remember, f of x is a y. Okay? So it is above here where all the y values are positive. So what do you notice about f of x? F of x is always positive. Not so. If it's below the line, it is where it is negative. So f of x is always positive, so this one is not going to apply to us. Not so. So the f of x is always positive, so we're going to look where the inverse graph is negative. And where's the inverse graph negative? From 0 till 1. Can you see it's only negative there? Okay, so what do we say? Therefore, is this a continuous or a bracket solution? Continuous. X is greater than 0 but less than 1. Right, so what do we say about at 0? What happens at 0? Can it be equal at 0? Wow. Why? Undefined. Not so. Can it be equal to at the 1? Why not? Okay, so it's undefined at 0, so I'm going to omit the equal sign here. But because it's equal to 0 at 1, I'll include the equal sign. Okay. That brings us to the end of the examples for exercise 4. For exercise 4, to the exercise 3. So why let me write exercise for you? Right, let's see for exercise 4. Or exercise 3, sorry. It's 1.1, 1.2, 1.3, 1.4. Okay, so it's basically the whole exercise. Okay. People enjoy the rest of your day. Good morning, class.